Hello, Math 1046 gang. It is Tuesday, May the 23rd, and this session is the first live Skype session for Unit 2. So we finished Unit 1 on Friday, and this week, which is week 5 in our 14-week, or is it 15-week? Let me see. Just checking my notes here. Nope, 15 weeks. So this is week 5 in our 15-week course. So still 10 more weeks to go, but we have finished Unit 1. So just a couple of things regarding Unit 1. Your marks are now up in D2L, except for the sticky question discussion, which I will have completed this week. Remember that there are 2 criteria in order to pass the Math 1046 course. That is an overall grade that is 60% or above, and that you are successful at passing all the tests individually, and the pass mark for each individual test is 60%. If you if you weren't successful on the Unit 1 test and you haven't touched base with me yet, please do so via email. Those of you that have talked to me, we've talked about how to move forward, and it's individual based on how you're doing in the course. So now everyone is on to Unit 2, and I'm just going to bring up D2L here for a moment. It's very quiet in the live session tonight. It's actually about 10 minutes after 8, and if I have latecomers, that is awesome. But I thought that I would just go ahead and share some things, even though it's a quiet session tonight, since I know many of you do watch the recordings to these sessions. I'll be posting review videos for Unit 2 up, which act as sort of the lecture for the course, and then these live sessions are just an opportunity for anybody that wants to come in on a Tuesday night and ask their questions face to face, or maybe even work in the background on homework and bring up questions as they go. That's really what this session is for. It's just having me in the room, and then over the hour you can ask me questions. So I'm just going to present my desktop here. And I'm going to bring up my D2L. And I'm in our Math 1046 course, so I'm going to go into content. And we have gone through the welcome unit. We're through the 1-week refresher. We are now through Unit 1 number theory, and we have moved on to Unit 2 polynomials. And you can see that the textbook sections that we're covering in Unit 2 polynomials is P5, 3.3, P6, and P7. So we do have all chapter P's in that PDF that I sent, but also you may have noticed that the Texidium link is now working, and you can access all of these sections and 3.3 through that Texidium link, or through the My Math Lab content section. You have an e-textbook there as well. So at the top of this, you can see that this unit is due June the 9th. So there are 3 weeks to work on this unit. And I always like to do 1 or 2 sections a week. So my suggestion would be that this week you concentrate on P5 and 3.3. And that's because that's going over what a polynomial is, how to add and subtract and multiply polynomials, and then Section 3.3 is how to divide polynomials. So those 2 sections go really, really well together. And I recommend that students do those all in 1 week together. P.6 I would leave to the 2nd week, and that's about factoring polynomials, and that will require a lot of practice. So P.6 should be the 2nd week. And then the 3rd week is all about P.7 rational expressions, and you'll need the weekend before. You'll need a full week for P.7, so don't leave P.7 to the last couple of days. It is a bit of a a branch off from polynomials, so it's good to do give yourself at least a week for p.7. So again, put p.5 and 3.3 together, do p.6 by itself for a week and p.7 by itself. And you can see that in Unit 2 there is a what to do section, and that will give you a little bit more information on what to do this unit. You're going to have My Math Lab homework, which is worth 30% of your mark. You're going to have a My Math Lab pre-test worth 10% of your mark, and the unit test is worth 50% of your mark. Under resources, you're going to find videos that accompany all of these sections. And then also don't forget that I will have some review videos listed in the news feed as well. You're going to have another discussion assignment. So in Unit 1 you had a sticky question assignment. In this one, this discussion is a teach a method assignment, and you can see that we have the instructions down here. And then, of course, there's the gut questions. If you have any questions that you'd like to post, you can put it down here in the Q&A for Unit 2. So we have 3 weeks for this Unit 2 polynomials and 4 sections to cover, so you're going to want to make sure that you schedule that out for yourself. And if you have any questions, you can bring that up to me either through the Q&A posts, hitting that Ask Your Instructor Questions button, or via email. And just as a reminder, on my news feed, I did talk about the keys to success in online math, what you need to do. And I always like when students start with the textbook and get an idea for each section, taking each section individually, doing the homework for each section individually, but starting with the textbook first, so you can see how each of the skills blend into each other to build up your skills. And you can start with the textbook by doing the checkpoints and end of section exercises, then going ahead and practicing with your My Math Lab homework. Remember to ask questions and watch videos. Try a pre-test. Maybe the earlier the better, so you can see what types of questions we're going to be asking on your test. And don't forget that you can ask me questions from the pre-test as well, and you get 2 attempts. So your first attempt doesn't have to be your best attempt. We just take your best mark from your 2 pre-test attempts. Ask more questions, polish up your skills before your test based on how you do on your pre-test and your homework. Do the test, and don't forget to review the test and gradebook. So if you haven't reviewed your Unit 1 test, you just need to go into My Math Lab and then choose this second link, and we'll see if it comes up. There we go. It's taking a little bit of time. And then you're going to click on Gradebook. And when you click on your gradebook, it's not going to show up in mine because I don't have anything in here, but when you click on Gradebook, you're going to be able to see all of your homework pre-tests and tests. So you just have to click on the test, and then you can go over your questions, see what your answers are, see what you got right or wrong. And then if there is anything from your test that you think that you deserved partial marks, or maybe you had the right answer, it just wasn't accepted by the computer, let me know, because I can help you with that and give you some extra marks, and maybe even bump your overall mark up a little bit. If you haven't been using the study plan is a great place to, as you're working through your homework, there are practice problems and quiz me problems based on how you're doing as you're going through your unit. So if you haven't looked at the study plan yet in My Math Lab, maybe for Unit 2 you use the study plan a little bit more. This is not for marks, this is just added practice, but it's individual to each student, so it's going to be dynamic. It's going to look at how you do on your homework and your pre-test, and then it's going to assign extra practice based on those parts that you need extra help in. So that's a great one as well. So I'm going to stop presenting my desktop. There we go. And I'm going to bring up the whiteboard. Oh, I'm going to clear what I have there. And I just wanted to start you off on a little bit of introduction on Unit 2 and P.5. So I'm just going to grab my pen. So P.5 is really an intro to polynomials. And you'll see in my review videos when I talk about polynomials and what to expect. But basically a polynomial is either a single term or the sum of two or more terms containing variables with whole number exponents. And what a term looks like is, as it says, a whole number, so let's say 6, with a variable, and the variable is a letter. It can be X, it can be A, it can be B, and on that letter you might have an exponent like that. So this whole thing is called a term. Whoops, a term. The letter is known as the variable because we can assign any value to this variable. And then the number in front of the variable, that whole number, is called a coefficient. And it's the coefficient, the variable, that make up the term. And you can see that the variable can have an exponent as well, or it cannot have an exponent. If there's no exponent, then we assume it to be 1. Now the standard form for a polynomial is that you always write the powers in ascending order. So if you have a polynomial like this, this is a very long polynomial. You'll notice that we're writing it so that the first term has the largest exponent right here, and then we write the terms in descending orders. And you can see that between the terms you might be adding, you might be subtracting, that's all okay. But each of these terms are all separate, and we're writing them in descending order. You can talk about the degree of a polynomial by looking at the largest exponent on the term. So in this case, our largest exponent is a 4. So we call this a 4th degree polynomial. If we just had this term alone, this is a polynomial, it's one term, and this is a 2nd degree polynomial because we have the exponent 2 on this variable. So the degree of a polynomial is always going to be the largest exponent for the term. Some more terminology that goes with this is monomial versus binomial versus trinomial. And a monomial is when you just have one term. A binomial is when you have two different terms. So you can see here that I have 6x to the power of 3 minus 2x to the power of 2. These terms are unlike because their variables, x to the 3 and x to the power of 2, are different. So the exponents make them different. So this is a binomial, 2 terms. And then you can also have a trinomial where you have 3 terms. So a monomial is a polynomial that only has 1 term. A binomial is a polynomial that has 2 terms. And a trinomial is a polynomial that has 3 terms. So you'll see that all on the review session. So one of the things that we're going to look at in this P.5 is adding and subtracting and simplifying polynomials. So one of the things that you might have is something like this. Oh, that's a 3. All in brackets. And then we're going to subtract . And then what they want us to do is simplify this polynomial. This is a polynomial because we have terms with variables in it, and we have several of them put together here. So to simplify this, the first thing we're going to do is do order of operations, where we're going to remove the brackets. Now the first brackets that are in this first expression, or part of the expression, you can see that we have brackets here and here. To remove them, we just take them away. So we just write this down as is. Now if there was a negative in front right here, then we would apply that negative to everything inside, and that would change things, but there's nothing in front of the brackets, so we can just safely remove the brackets, the parentheses, and not change anything. Now the second part of the expression does have a negative sign in front. So in order to remove the parentheses, we have to apply this negative to everything inside the parentheses. So that negative is going to change the sign of everything inside the parentheses when we remove them. So positive 3x cubed becomes negative 3x, positive 2x squared becomes negative 2x squared, negative 8x becomes positive 8x, and negative 6 becomes positive 6. So we've now successfully removed the parentheses in this expression. Our next step is to combine like terms, and like terms are going to be terms that have variables with the same exponents. So looking at this, I can see that negative 9x cubed is like to negative 3x3, all because they share the same variable and exponent. So I'm going to combine those terms. Negative 9x cubed subtract 3x cubed is the same as adding the two negatives together. So I'll get negative 12x cubed, because negative 9x cubed subtract 3x cubed is going to give me negative 12x cubed. Then I'm going to go forward and find more like terms, and I can see that as I go down, x squared are going to be my next like variables, and I have positive 7x squared subtract 2x squared, and that's going to give me positive 5x squared, because 7x subtract 2x squared is 5x squared. I always like to kind of cross out once I'm done combining the like terms so that I know that I've already done that. My next one is going to be just the variable x, and I have minus 5x plus 8x. That's going to give me plus 3x. Those terms are done. And then finally, I have positive 3 plus 6 is going to give me positive 9. Now looking at this polynomial, I have combined all of my like terms. There isn't anything else that I can do there except put it into the standard form, which makes sure that my variables are in descending order in terms of my exponents, and I do have that 3, 2, 1, and this would be x to the power of 0 if I wanted to put that in. So this is my simplified version of the polynomial, and would be my answer. So you're going to look at doing some adding and subtracting of terms to simplify polynomials in P.5. You're also going to be looking at multiplying polynomials, and first of all we look at multiplying a monomial by a binomial. And what we notice is that whenever you multiply a monomial by a binomial, you're going to multiply everything inside the parentheses by what's outside. So we're going to take 3x squared and multiply it by 2x cubed. And how we do that is we multiply the coefficients first. So 3 times 2 is 6, and then we're going to multiply x squared times x cubed. And whenever we're multiplying variables with exponents, we add the exponents. So x squared times x cubed gives us x to the power of 5. So 3x squared times 2x cubed is going to give us 6x to the power of 5. And then we need to do the same thing, 3x squared times negative 7x. 3 times negative 7 gives us negative 21. And x squared times x to the power of 1, we're just going to add our exponents together, and we get subtract 21x to the cube. We're going to look and make sure this is the reduced most simplest answer. Looking at these two variables, they're not like, so we can't combine them. So this is as far as we go. This is the simplified version of this multiplying a monomial by a binomial. We will also look at multiplying binomials by binomials. So we could have 3x plus 2, which is a binomial, and 4x plus 5. Whenever you're multiplying a binomial by a binomial, we're going to use a process called FOIL. FOIL stands for first, outside, inside, last. First meaning that we're going to multiply the first term of the first binomial by the first term of the second binomial. So we'll have 3x times 4x. So that's going to give us 12x squared. Then we're going to do the outsides, which are going to be our term 3x times 5. So 3x times positive 5 is going to be positive 15x. Then we're going to do our inside terms, which are these two. So 2 times 4x equals 8x, and then the L in FOIL is the last term, so the last terms 2 and 5 give us positive 10. 2 times 5 gives us positive 10. That's how you multiply binomials together. You're going to use this FOIL method of multiplying your first terms, your outside terms, your inside terms, and your last terms. And this will give you a polynomial that looks like this. Your next step is to see if you can combine like terms, and I see that I have 15x plus 8x. So I can add those together and I get 8, 9, 10, 11, 12, 13. So 23x is going to be the combination of 15x plus 8. And then I'll just bring down the 10 and the 12x squared. And there is my simplified polynomial. So that's the FOIL method in multiplying. So P.5 is all about simplifying polynomials, adding, subtracting, and multiplying polynomials, and getting used to reducing polynomials. What I'm going to finish here tonight is just a peek at section 3.3, which is dividing polynomials. So when I'm dividing polynomials, I'm going to make sure that I'm doing okay with things. So hopefully my internet's working okay and my recording is going to be fine. We're going to look at two ways to divide polynomials. One is using long division, and one is going to be using something called synthetic division. So when you're dividing polynomials, you might get something like this: x squared plus 10x plus 21. So there's a second degree polynomial, and we're going to say now divide that by the binomial x plus 3. How do we do that? Well, I'm going to show you how to do this using long division. X plus 3 is my divider, and x squared plus 10x plus 21 is what I'm dividing. What I'm going to do is just take the first term in my binomial, which is x, and I'm going to say, okay, x squared divided by x. What do I have to multiply x by to get x squared? You might be able to see that x times x gives me x squared. So I'm going to put that right here. I'm going to move over one place and put that answer right here. And then, just as I would do in long division, I would take this x, multiply it by x, and then right underneath it, I would write that answer, which is, I'd write it under here. So x times x is x squared, And then I would multiply x times 3, which is positive 3x. And then I'm going to subtract. So again, I said x goes into x squared, x times x is x squared, and I make sure that I line it up underneath my x squared, and then x times 3 is 3x, and I make sure that that lines up directly under just the x variable here. And then I'm going to go ahead and subtract. So positive 21 subtract 0, I'm just going to bring that down, positive 21. Positive 10x minus positive 3x is going to give me 7x, and x squared subtract x squared is 0. And then I've now moved down to this level here, and I'm going to do the same thing. I'm going to say x goes into 7x how many times? Hopefully you can see that that's 7 times. And then 7 times x is going to give me 7x, and 7 times 3 is going to give me positive 21, and when I subtract that I get 0. So the answer to x squared plus 10x plus 21 divided by x plus 3 is going to be x plus 7. So that's finding out a division answer by using long division. Now let me show you what happens if you have a question that has a remainder in it. So let's look at this one. Let's say 3x minus 2 is our divider, and we want to divide 6x cubed minus x squared minus 5x plus 4. Make sure that what's under the division sign is in standard form, that you have it from you have it in descending powers. I'm going to take 3x and say, what do I have to multiply 3x by to get 6x cubed? That's going to be 2. 3 goes into 6 2 times, and x goes into x3 x to the 2. And then I'm going to multiply. 2x squared times 3x squared will give me 6x cubed. 2x squared times negative 2 will give me negative 4x squared. Then I'm going to subtract. I'll bring down the 4 and the negative 5x, and negative x squared minus 4x squared is going to give me, oh, and I'm subtracting, so negative x squared subtract negative 4x, that's like adding 4x, so that's going to be 3x squared. So just to show that, negative x squared minus 4x squared, the two negatives cancel out to make a positive, so negative x squared plus 4x squared is going to give me 3x squared, and of course 6x cubed minus 6x cubed is 0. So now I'm going to take 3x and see how many times it goes into 3x squared, and that's just going to be x. And x times 3x is 3x squared, and x times negative 2 is negative 2x. I'm going to bring that down, positive 4. Negative 5x subtract negative 2x is the same as saying negative 5x plus 2x, so that's going to be negative 3x. And 3x squared minus 3x squared is 0. And then 3x goes into negative 3x, negative 1 times. Negative 1 times 3x is going to be negative 3x, and negative 1 times negative 2 is positive 2. And when I subtract those, 4 subtract 2 is 2, and negative 3x subtract negative 3x is 0. So here's my remainder of 2. So my answer to this is going to be 2x squared plus x minus 1 plus my remainder of 2, and here's the catch, over 3x minus 2, my divider. So your remainder is always going to be over what you're dividing by. And if you can reduce it in any way, you're going to want to reduce that fraction, but 2 over 3 can't be reduced, so we're just going to save that. So my answer to this question is going to be 2x squared plus x minus 1 plus 2 over 3x minus 2, because that is the remainder. Okay. So that's doing it by long division. The last thing that I wanted to show you is synthetic division. So in synthetic division, instead of having the variables, you're just writing down the coefficients. So for instance, let's say that I had x plus 2, and I'm dividing that into x to the power of 3 minus 7x minus 6. In synthetic division, what we want to do is we want to write this into just coefficients. Now, positive 2 is always going to be turned to a negative. And if we had x minus 2, that would have been turned to a positive. So that's kind of the first thing about when you're dividing using synthetic division, is that whatever this is right here, it's going to be changed into its opposite sign. And then in synthetic division, we do a little line like this, and then we write down all the coefficients that are happening underneath the sign. So x to the power of 3, its coefficient is 1. There isn't an x to the power of 2, so we're going to write that as 0. You have to make sure that you do all of the in-between variables, even if they're not represented. So in this case, we have x to the power of 3. We don't have x to the power of 2, so we put 0 in as the place over. X to the power of 1 is this one, which is negative 7. And x to the power of 0 is this negative 6. So once we have all the coefficients down, what we're going to do is draw a line here, and then we're going to drop this 1 down. This first number, we're just going to repeat it below. Then what we're going to do is we're going to multiply the negative 2 by this first number, which is 1, and we're going to put that answer here. So negative 2 times 1 is negative 2, and then we're going to add these two numbers. So 0 plus negative 2 is negative 2. Then we're going to keep on going down. We're going to say negative 2 times negative 2 is positive 4, and we're going to put that here. And then we're going to add these two together. So negative 7 plus 4 is negative 3. Negative 2 times negative 3 is positive 6. And negative 6 plus 6 is going to give us 0. This position here is always going to be your remainder, and you can see that we have a remainder of 0, so this divided evenly. And then these numbers here become your coefficients, and it's always going to be 1 less than the degree you started with. So if we started with x to the power of 3, then we're going to have 1 x to the power of 2, subtract 2x, subtract 3. So the answer to this question is, when you divide x to the power of 3 minus 7x minus 6 by x plus 2, your answer is going to be x squared minus 2x minus 3. And that's how you do a question through synthetic division. Let me show you one other problem like this. So let's say we have x minus 3, and we're dividing x to the power of 3 plus 4x squared minus 5x plus 5. And instead of doing it by long division, we're going to do it by synthetic division. So the negative 3 becomes a positive 3. And then we're going to write all the coefficients down that we have, making sure that we include any variables that are missing. So x to the power of 3 is the highest of the exponents, and the coefficient in front of that is going to be 1. Our next degree would be x squared, and we do have that representing, so positive 4. X is our next one, which is negative 5, and then positive 5. So we actually don't have to put zeros in. All of our exponents are represented, so that's okay. Then what we do is we draw a line and we bring down that first number, which is 1, and then we're going to multiply. Positive 3 times 1 is 3, and then we're going to add these two together and we get 7, and then positive 3 times 7 is 21. We're going to add negative 5 plus 21 is 16, and then positive 3 times 16 is 48, and positive 5 plus 48 is 53. This number here is going to be our remainder, and our remainder goes on top of x minus 3. So 53 over x minus 3 is our remainder, and then this 1 is the coefficient of 1 degree lower than x to the power of 3. So we have x to the power of 2 plus 7x plus 16 plus 53 over x minus 3. This is our answer using synthetic division. So with that, I'm going to stop here. That's just an intro look at P.5 and 3.3. Thank you for watching. Remember that you really want to address these two sections this week. Leave P.6 for week 2 of the unit, and then finish off the unit with P.7, giving you lots of time that full week for P.7 because it is sort of a stretch in this unit. And remember, if you have questions, please let me know through the Q&A in Unit 2, through email, or via the Ask My Instructor button in the My Math Lab homework. Have a great study week, everyone, and thanks for watching. Bye for now.